All right, kids, we're looking at section 6.6 on properties of definite integrals. And so the first thing that they want us to do is figure out what the integral is from 0 to 12. You'll remember that's just finding the area under the curve or between the curve and the x-axis. Anything above the x-axis is positive and anything below the x-axis is negative. So let's figure out these areas first. I have a circle. It is half of a circle. So 1/2 of pi times 2 squared, and I'm just going to give you these because I know we talked about this in previous sections. That's a value of 2 pi. And then I'm going to split this next one. I know we could do a trapezoid, but there's going to be other questions that they might ask us that, anyway, I'm going to do the two triangles and the rectangle. So this has 1/2 the base times the height, 1/2 of 2 times 2, so that gives you 2. This guy's a rectangle, a 1/2 rectangle, so he's a 2. This one is a triangle again that is 1/2 of 1 times 2, which gives you 1. Then you're down here at this guy. He does the same thing, 1/2 of 1 times 2. He's 1, but he will be negative because he's below the x-axis. And then we have a triangle, 1/2 the base of 3 times the height of 2, and that gives you a value of 3. Again, that would be a negative value. And so they're asking us what is the integral from 0 to 12. So I'm going to add them all up. I have 2 pi plus 1, 2, 3, 4, 5 minus 1 times 3, or 1 plus 3, and that's 4. And so if I look at that, it's 2 pi plus 5 minus 4, or 2 pi plus 1. And so that's the first one. That's not kind of anything new to you. We've seen that before. When you get to number 2, check out your bounds. Your bounds are all messed up. And the reason why they're messed up is because the lower bound needs to be your smaller number. And they have it all backwards. So there is a property, and actually it's this guy here, that when the bottom number is bigger than the top number, you're allowed to reverse it. So you're allowed to take the A and the B, and it's actually kind of like looking at it from left to right instead of right to left. You're going from 12 to 0 rather than 0 to 12. So you're looking at it from left to right, from right to left instead of left to right. If you change those bounds around the way that you want to, all you need to do is put a negative sign in the front. That's the rule. That's the property for integrals. So if I want to change this around, it's going to be a negative integral from 0 to 12 of my function f of x with respect to x. Well, I already figured out what it is from 0 to 12. Now I need to make it negative. So it's negative 2 pi plus 1. When I distribute the negative, then it's going to be negative 2 pi minus 1. And that's your answer. So this is something that's going to come up quite a bit where you need to change your bounds. So when you look at your bounds, you want the smaller number on the bottom, the bigger number on the top, and if they give it to you the other way around, just switch it and put a negative. Makes it pretty easy. All right, here's another property. If I have my lower bound is A, my upper bound is A, in other words, they're the same number. Say they're both 4. It's 4 to 4 of, actually no, this guy, 4 to 4 of the function. Have you gone anywhere? Did you accumulate any area? And the answer is no, you haven't gone anywhere. You started at A and you stayed at A. So you did not accumulate any area. So this one is 0. If the bounds are the same, it doesn't accumulate any area. Kind of makes sense, right? So your answer is 0. If you have a constant of some sort, k, that's being multiplied by this, you're allowed to pull that constant out. K times the integral from A to B of f of x dx. You're going to see an example of that in just a minute. Kind of like number 5e. Let me show you what it looks like. Number 5e. This guy here has a 3. That's a constant that you're allowed to pull out in front. So we're going to do that when we get to that problem. So that's it, the constant rule. And then this rule, the next one, is kind of, this reminds me of segment addition from geometry. I don't know if you remember segment addition, but if you take one segment, here, let me give you my hands, one segment, and then add it with the next segment, then it's going to equal a total of the whole thing. This is saying the same thing. See how C is between A and B? So you'd have like 1 to 3 and 3 to 5. Well, that would be the same thing as 1 to 5. So that's what this last one is, that you're allowed to add these up. This would be the integral from A to B for f of x dx. You add the piece from A to C, add the piece from C to B, you get the piece from A to B. That only works if C is between them. All right, addition property. This one says that you can take the integral from A to B of f of x dx and add it with the integral from A to B of g of x dx. Same thing works for subtraction. The integral from A to B of f of x dx minus the integral from A to B of g of x dx. Now this one is the same picture as what you have up above. So now they're giving you a few more problems to look at. It's the same picture, so we already know what these different areas are. We're just going to use the picture from up above so we don't have to redo it. I'm looking at this first one and I see that my bounds are 6 on top and 7 on the bottom. I don't want that. That doesn't work for me. I need to change it around because I need the smaller number on the bottom. So it's going to be a negative integral from 6 to 7 of f of x dx. Again, when you change the bounds, you got to put a negative out in front. So what is the area from 6 to 7? 6 to 7 is just this little rectangle. You can see up above that that has a value of 2. And so this would be an answer of negative 2 because the negative is out in front. You change the bounds. Same thing goes for the next one, but the next one also has a 3. So this guy would be like the same thing as 3 times the integral of 8 to 12. Smaller number has to go on the bottom, but that means I need a negative with it. So I'm going to put a negative with that 3. And then I am f of x dx. So I have negative 3 times, what's the area between 8 and 12? And if I look at my area up above between 8 and 12, it is 1 plus 3. However, they're under the x-axis. So it would really be, well, it's 4, of course, when you add them up. But it's going to be a negative 4 because it is under the x-axis. So negative 3 times negative 4 gives me an answer that is 12. Okay, here comes the next kind. And these are all properties of these integrals as well. So they gave you 3 facts. You know that between negative 2 and 1, that f of x dx is 4, has an area of 4. You know between 1 and 5 that it has an area of negative 3. Between negative 2 and 1, g of x, different function, has an area that is 8. Find the following. First one's this guy. I don't like the 5 on the bottom. He's too big. So I'm going to flip it, make it negative. Negative 1 to 5 of f of x dx. Do I know what it is for 1 to 5? Let's see. 1 to 5, f of x, is a negative 3. So really, it's a negative 3. And that gives me an answer of 3. The next one's perfectly fine with my negative 2 to 5. My bounds are in the right places. Do I have a negative 2 to 5? I do not, right? But I have a negative 2 to 1 and a 1 to 5. So it's kind of like that segment addition one where you're forgetting about the C thing. So it's what you're going to do is take the integral from negative 2 to 1 that you do know and add it with the integral from 1 to 5 that you also know. From negative 2 to 1, from 1 to 5 is the same thing as going from negative 2 to 5. So go up here, negative 2 to 1 is 4. 1 to 5 is negative 3. And so I get an answer when I add them up of 1. Next one. If I'm adding two of these integrals, I can separate them. Negative 2 to 1 of f of x dx plus, see how now I have a constant, 2 times the integral from negative 2 to 1 of g of x dx. So I go up here, negative 2 to 1 of f of x is 4 plus 2 times negative 2 to 1 of g of x is 8. And so 16 plus 4 gives me an answer of 20. Next one goes from 0 to 1 of f of x. So I'm looking, these are the only facts I know. They didn't give me a picture, they didn't give me a function. All I know is what it's doing from negative 2 to 1, from 1 to 5, negative 2 to 1. Can I figure out what it is from 0 to 1? Can I maybe subtract away? And the answer is no. So this one's one of those can't be determined. There you go. Here's a constant one. Again, my bounds are in the wrong order. I need the negative 2 on the bottom. I need the 1 on the top. That causes me to have a negative in front. I have a constant there, so it's going to be negative 3 in front. So negative 2 to 1 of f of x is 4. Negative 3 times 4 is going to give me a negative 12. And then the last one, f, goes 5 to 5. It hasn't gone anywhere. It starts at 5, it stops at 5. It hasn't accumulated any area, so that's that property that says that that guy's 0. Okay. We're going to flip the page and look at a few more examples. He's got quite a few examples this time around. Not as many practice problems. The first one's talking about a piecewise function. What happens when you get a piecewise function? So we need to graph it to see what's going on so we can figure out the areas. So it is 3 when x is less than 2. Well, 3 is like y equals 3 when x is less than 2, not equal to. So right here, there's 2, 3. And it's 3 everywhere to the left. And then to the right, it's 4 minus x. Now I'm just going to kind of lightly do this. 4 minus x, that means I have a y-intercept of 4 and a negative slope of 1. So the next point would be here, next point would be here, and so on. Now this is a closed circle at 2, and then the rest of the line goes like this. Graphing a piecewise function. We haven't done that for a while. What is the value of the integral from 1 to 5 of g of x, of this piecewise function? So I'm going to kind of look at this from 1 to 5, and I don't know that my line is all that great, but here's what you got. Even though there's a gap right there, you can still calculate out its area in that little region. This graph goes to 5. Even though there's a hole going on in between there, you can still calculate out that area. So it's okay to have a gap. That's what I wrote for this guy. Okay to have a gap. And so if I look at it, I've got a rectangle, right? 2 by 3 rectangle. Oh, actually, you know what? I messed up because it's going only from 1 to 5, not 0 to 5. Thankfully, I have a highlighter that is erasable. Right, it's going from 1 to 5. There we go. So I have a rectangle that is a 1 by 3. I have a little triangle here that is 1/2 a base of 1 but a height of 2. I actually think it should be, maybe it's my bad. The height of 2 and a base, it should be a height of 2 and a base of 2. Yeah, that's kind of what it looks like. Height of 2 and a base of 2, half of that would be 2. Minus. And then I've got this little triangle here. It should be 1 by 2, the base and the height. 1 times 2, and that gives me 1/2. Actually, I wish I had drawn my line better. I'll tell you the truth. It turns out that this little area here is 1/2. It's below the x-axis, and with a more accurate picture, it would probably be a lot better, but that's what the deal is. So, 3 plus 2 is 5. 5 minus 1/2 gives me 4.5. Next time I'll draw a better picture. 7. What's the value of the integral from 0 to 5 of the absolute value of x minus 2? Absolute value of x minus 2, we all know that that looks like a v. But do you remember from translations how the minus 2 affects it? Hopefully you do. It has a slope of 1. There you go. Look at that. I made that one perfect. It moves it right to. That minus 2 moves it right to. And so if I go the other way, I'm going to move my paper for a second so I can make it better. All right. Looks like this. This one is going between 0 and 5. And so if I look at my highlighted area, 0 to 5 would be this triangle and this triangle. All right, 1/2 the base times the height. 1/2 of 2 times 2 gives me 2. These are both above the x-axis, so it's going to be plus. 1/2 of 3 by 3, so 1/2 of 9 is 9/2. Well, this is 4.5 plus 2 more, and I get 6.5. And so there's your story for number 7. Number 8. This one's a little bit confusing. But the difference between absolute values being outside of the integral versus absolute values being inside the integral. Let's see the difference. This one is going to be the absolute value of what the area is going between -2 and 4. So I'm looking at this picture. This picture is different than ones we've seen. This guy here would be half of a circle, so half of pi r squared, that's pi over 2. This guy's the same thing. This one's a triangle, 2 by 2, and its base and height, so it's got a value of 2. So this one's going to be the absolute value of -pi over 2. That's the first thing you've got. -pi over 2. Plus, this guy's above the x-axis, so plus pi over 2. And this guy's above the x-axis, plus 2. Take the absolute value when you're done. These knock each other out, they're 0. So you've got the absolute value of 2, which is 2. Now, here's what this one looks like. He didn't go and do a picture for you, but I think that the visual of what you're looking at for this makes so much more sense. What happens is anybody that's below the x-axis becomes above the x-axis. So this below the oh, I should put it, well, that's fine, it's there. This guy here needs to go above the x-axis. This guy here is already above the x-axis, and then you've got the line going off this way. So when I'm looking at the absolute value of the function, here's what it looks like. So what's your area now? Your area is going to be pi over 2 plus pi over 2 plus 2. Well, half a pi and another half a pi give you a whole pi, and now you got pi plus 2. So anything that's below the x-axis comes up above the x-axis, and it would end up looking like a picture like this. And when I look at this, pi over 2, and 2 makes sense. You're just adding them up. And then the last thing he did was used his calculator to calculate these out. Now we have a different calculator, and ours is way easier. I was doing this with Hannah today in class, and she was like, oh my gosh, this is so, so much nicer than what he was trying to do. So what you're going to do is grab your calc. I want it so you can see what I'm putting in there. Okay, that's probably pretty good. So in your y equals, for us, in your y equals, you're going to put in what the function is. Oh, I already have it in there. Must have checked it. I put it in, you can put it in as a square root, absolutely. I put it in as being raised to the 0.5 to the 1/2 power. Doesn't really matter. So in my y1, I put x minus 1 to the 0.5 power. That's how I put it in. And then what you're going to do is graph it. So graph it. And there it is. There's my graph. And then what you're going to do is hit F5, and it gives you this whole list. We want number 7, the integral. So 7, enter. And then it says, what's your lower limit? We go over here, it's 2. What's your upper limit? That's 3. Oh, it didn't like something. Let me try it again. All right. F5, number 7. Lower limit is 2. Upper limit is 3. And there's the answer, 1.219. Very simple to put it in that calculator that way. If I do the second one, this one is going to be, in my y equals, take out the other guy, x over 3, x divided by 3. I might want to put that in extra parentheses, just so it understands. X minus 3 minus 1. So here's what it looks like. Okay, I'm going to graph it. It is a straight line. There it is. And so I want to calculate what the integral is, so I'm going to go F5, 7. My lower bound this time is a -2. My upper bound is a 4. It even shades it. It's kind of cool. My answer is a -4. So in my margin, what I want to do is give you the steps again so you can write them down. So you're going to put in your y1 whatever the function is. And then you're going to graph it. Now, are there other ways to find these integrals? Absolutely there are. They're from the home menu. You can do it from there in like the algebra-ish menus or math menus there. This I find to be the easiest, and I tend to like the pretty picture. You graph it, hit F5, go to number 7, put in the lower bound, whatever that might be, put in the upper bound, whatever that might be, and then press enter and it'll give you the number. So really simple. He had all sorts of things going on with his TI-84 or whatever it was. But yeah, for us, for our calculator, that's the story. Okay, so then we're into practice problems. And I found the practice problems to be almost identical to the example problems. I didn't see anything here that was rocket science other than number 20. So I'm going to do number 20 with you, but I'm going to leave you these other ones because they're all very similar to ones that we had done as examples. All right, 20 it is. This one had some things that make you think. Now, some of the things that you need to remember when you're looking at these graphs for number 20. And the first thing is they tell you the graph of the function is shown above. Let g be the function defined by g of x equals the integral from 2 to x of f of t dt. So one of the things that you need to notice is that if you're looking at g of x, you're looking at the integral. If you're looking at the integral, then you want to know what the area is, right? So g of x is the integral, therefore you're looking at the area. But the other thing that you need to be aware of is that the derivative of this, g prime of x, because of the fundamental theorem of calculus, actually is the same thing as the original function, because derivatives undo integrals, they're inverses of each other, and you end up with just what the function is. So there's some things to keep in your brain as you go and answer these questions. All right, average rate of change. Average rate of change. So if I want the average rate of change of g is area, from -4 to 6, I'm looking at average rate of change, g of 6 minus g of -4, all over 6 minus -4. Right? Average rate of change is like the slope. And so you're looking for the slope. And if you think of it with what they gave you, it's g of 6 minus g of -4 over g minus -4. Now here's where it gets a little dicey. You want to know, which by the way, let me figure out our areas here first before we even get into it. This first triangle is a 2 by 4. Half of that is 4. Now he divided this up into triangles. He always does that. I don't know if it would have been easier to do a trapezoid, but nonetheless, I have a base of 1 and a height of 2. That gives me a value of 1. This rectangle is a 3 by 2, so that's 6. And this triangle is a 2 by 2, base and height are 2, so you end up with 2. And then this little guy right in here, he's a half. He's a halfer. And then the last guy is a 1. So it's kind of easiest, since you're looking for the area, to divide that up and find your areas. Now, g of 6, I think I can go up here. G of 6 would look like this. It would be the integral from 2 to 6 of my function. So I go to my picture. What is the area from 2 to 6? It is a negative 2, this guy here, above the x-axis to 6 is 1.5 plus 1.5. That's g of 6. Minus g of negative 4. Now that's a little bit crazier because g of negative 4, I wonder if I can fit it in here. G of negative 4 would be the integral going from 2 to negative 4 of f of t dt. Well, remember we have to have the lower bound being the smaller number, so we need to flip it, which means we need to go negative, and then it's going to be the integral from negative 4 to 2 of f of t. Ooh, I'm not writing that very well, dt, but you get the idea. Now, how's that going to affect this sign here? If it's negative, then we're going to change this to a positive and move on with our area. What is the area between negative 4 and 2? Well, negative 4 would be 4 plus, actually 4 minus, right? 4 minus 1 minus 6. 4 minus 1 is 3. 3 minus 6 would be 3, right? I guess I could put it this way. 4 minus to 2 would be 7. If I take this triangle and that part right there, 1 plus 7. And all of that is over 6 minus a negative 4, so it's over 10. All right, so what is this, right? This would be a negative 0.5. This would be plus a negative 3 over 10. So you get negative 3.5 over 10. I think they went on and turned it into fractions and such in their answer, but really that's the same. You don't tend to like decimals and fractions mixed together. I'll show you just for the kicks and giggles. Negative 3.5 would be negative 7 halves. If I have negative 7 halves divided by 10, keep, change, flip, I have negative 7 halves times 1 over 10. That gives me negative 7 over 20. That's probably the best answer, so that you don't have decimals mixed in with your fractions. All right, the next one. Find the instantaneous rate of change of g with respect to x at x equals 5, or state that it doesn't exist. Well, if I want instantaneous rate of change, in other words, they're asking me, what's the derivative at 5? All right, let's go over here. The derivative is equal to whatever the function is at 5. Well, the function at 5 is 1. I'll put it this way. Equals f of 5, which is 1. That one was easy peasy if you understood what they were talking about, right? If you made the connection between the derivative and the function. On what open interval C, if any, is the graph concave down? Well, we know it's going to be concave down when g double prime, second derivative, is negative. How can I figure out where it's negative, where the second derivative is negative? Well, this is a picture of the first derivative. And so if I want to think about the second derivative, then I have to think about slopes. The slope of g prime. Where is the slope negative? And the only place it's negative is from negative 4 to negative 1. There's your interval when it's concave down. All right, last one. This one wants to know, find all the x values between -4 and 6 at which g has a critical point. Classify each critical point as the location of a local minimum, maximum, or neither, and justify your answers. Well, that's going to happen when your derivative changes from positive to negative or negative to positive. G prime, which is this function that I'm looking at right here, changes from positive to negative right here at -2. So I got something going on at -2. Is it a maximum or minimum? Minimum. G prime of x changes from, it's above the x-axis and it goes below the x-axis. So from positive to negative. Now think about that. If I go positive to negative, I have created a hill, and that's going to be your maximum. There you go, because. And likewise, the only other place it crosses the x-axis is over here, but this time it goes negative to positive. And so that means at x equals 4, you're going to have a minimum because g prime of x, or f of x, changes from negative to positive. All right, and there you have it. That's section 6.6. I will see you again for section 6.7. If you have any questions, though, give me a buzz, shoot me an email, and I'd be happy to help you out. I'll talk to you soon. Bye.